Well, all right, so the answer for this one, like I said, was B, right? A was false because when it approaches 5 from the positive side, it's clearly approaching 0. That would be the reason. B was true. You can see that it approaches 8 from the negative side. It's approaching 3. The function is approaching 3. C is false. The limit does exist. It approaches 2 from both sides. And D is false because the limit on that one does not exist at x at x approaching 2, because when it approaches from both sides, they approach different numbers. Okay, so those are the answers there. Why it's which one's true, which ones are false, and those are the reasons, right? Reasons, again, you could just write down what they actually equal to instead of writing down full sentences, unless you want to write down full sentences. All right, you okay with that one?
Yeah.
All right. Let's go back and finish up this extra technique that I was trying to show you yesterday, but I was being rushed and I realized that the problem I gave you was wrong. So I figured an easy way to fix this. You ready? Instead of it being plus 7, can you guys change that plus 7 to a plus 17? So just add a little 1 in front of it. That way this will work out the way I want it to work out. So put it as plus 17 on this problem instead of plus 7. And that's because this down here needs to be a positive. What would that make this, by the way? What would that be? 17 minus 9. 8 it is. You got 8, right, Esther?
No, she didn't.
Right? Esther, right? 8? 8 is what you said?
Yeah.
Yeah.
What happened?
You read my mind.
8 was the answer I heard. Nita?
Why did you change it to 17?
Because we were trying to show the arctangent, right? And arctangent needs to be a squared plus u squared, right? Or u squared plus a squared. And if I didn't make that 17, I would have ended up with u squared minus something, and you can't have it as a minus. It won't work. Arctangent only works if it's this format. Does that make sense?
Yeah.
So that's why I had to change it, because we would have been screwed if it was the other way around. All right. Now that I have this written like this, hopefully you can see that this is very similar to the integral of an arctangent, right? It's du over a squared plus u squared, yes? You guys remember what the antiderivative of this is, by the way? It's not just arctangent. 1 over a arctangent, very good. And what's inside the arctangent? U over a plus c, yes? So our job now is just to figure out what the heck is our a and what the heck is our u. So what's u? X minus 3. Therefore, du is equal to dx, right? What's a in this case?
8.
Not 8.
Right.
3.
Not 3. Do you want a hint?
8.
A is not 9. Oh, hold on. What's a squared? Let's do that first.
Oh.
No, I have them switched
9?
around. Not 9.
8.
8. Do you see how they're switched locations? Do you see it? I have them switched around.
No, I don't see it.
No, they act like we can't see them. But I can literally see.
Are they still outside?
Yeah.
Oh.
I can literally see who just knocked.
Sitting there.
Oh.
He went to go back sit down, and I just looked at him.
They're just waiting out there.
Okay.
All right. I guess I should call somebody.
Or you could just. What teacher
Call
is
the
that?
bush
Go
out.
out there.
Can I go?
No.
That's a
You're not
bad
that
idea.
material in life.
So then,
I don't
Not
like
really.
it.
that's gonna be 2. I know, that's why that's a bad idea.
I just want to do it.
Bunch of students that are just sitting outside the classroom of A322.
This is for
Yeah, I think there's
It's gonna be 2 square root 4.
All right.
Knock me. Is that gonna be 2 square root 4? Or whichever one. Or 4 square root 2. I don't know. Oh, it's just gonna be square root of 8.
Yeah, square root of 8. But if you want to simplify it. So,
Oh, because you didn't want it. You said that we could just keep it like that.
Yeah, yeah. But if you really wanted to, a is going to be the square root of 8. If you really wanted to, you could simplify that. That's going to be 2 square root of 2.
Oh, two.
It's because the 4 gets broken out, comes out as 2.
Do you have water?
I do not. I normally do, but I am all out. So that's my a value, yes? So this integral right here is going to be equal to what? 1 over, what's a?
8?
No.
I mean, square root of 8.
No, yeah, square root of 8. Or 2 root 2. Either one are acceptable, right? Times the arc tangent of, yeah, what is u in this case? X minus 3 over square root of 8 plus, you're done. Let's do another. All right, let's do another. But I'll give you a second to write that down. Now, how important is this technique? I'm telling you right now, this is my disclaimer. You see a problem like this and you forgot how to complete the square, you skip this one. If it's on the free response question, well, you probably shouldn't skip that one. you're gonna have to try and struggle on that one. But honestly, this is what the only time I've seen this question on all past exams have always been on the multiple choice section. They have not shown up on the free response questions yet. But if it does, you can take some time to struggle on it to see if you can remember it. But honestly, I don't think it's worth the time on a multiple choice question. I would just let it go. If you have time after you've done all the other questions and you work your way back and you're like, I have time to do this, then try it. Okay? Don't waste more than like 3 minutes at the start. Waste more than 3 minutes after you finish everything else.
Isn't this plastic?
It's wood enough. Second thing.
How do you know? How do you know what number you're supposed to plug in? Like the.
Okay, let me show you another one. All right? So let's do another one here, and hopefully I can make one up. All right, here we go.
Hopefully, you can make one.
Well, because he knocked on it.
So there we go.
Knock on wood.
Here we go. So let's say I have here the integral of dx over, I want to do one with not tangent because we just did one with tangent.
Hey.
Mark.
Okay.
All right, got it. Mark you absent. Perfect.
Oh, you're funny. Was that Nita? What's up, dude?
What's
You haven't seen her for like a week.
I mean, he hasn't. Are you recording still?
Yeah.
Are you still recording?
Yep. All right, here we go.
He's mad he making all jokes.
Knock, do you still record these?
Yeah.
You didn't do that to me.
Hello. COVID?
Oh, is that you?
Hi, AJ.
All right. So let's say I have something like this. Let's say I have here the integral of 8x minus x squared. Okay? Now, wait, do you want it easier or hard?
Just leave it like that.
Can we get like a,
Is this
easy?
medium?
This is a medium.
Okay, we'll do that. Let's do this one.
I figured about it.
We have to
Say
always
hard,
complete
I was
the
like,
square?
Not always.
Okay.
So here's the thing. If I gave you a problem that looked like this, dx over the square root of, let's say it was 9 minus x squared, you can kind of tell this is going to be the arc sine. Yes?
Yeah.
And you can kind of tell it's arc sine, and you can also kind of see that this a right here is equal to 3, yeah? And u is just equal to x, right? So the antiderivative of arc sine, right, was what? Do you remember what it was?
I think it was 1 over 3 or 9. I think it was or whatever 3 is.
What?
Oh,
All right. Let's pull them up.
This is why we need a quiz.
Isn't it our side over 8 plus 3?
I believe.
We do need like Can you make one for us? Since we're the only ones asking for it.
Honestly,
Can you
if
make
you
one
make a
for
quiz
us?
after school for me and Stern.
Yeah. And Steven.
Oh, no. I know. Isn't it 1 over 3 arc sine to the 3x? Or arc sine to the x. 1 over 3 arc sine x.
Is it x or x over 3?
X over 3.
Yeah.
Wait, so that's the antiderivative.
Yeah. Arc sine.
Wait, that's arc tan though.
Let's see here. Let's look it up real quick.
Wait, what were we finding?
The antiderivative of arcsine.
Oh, I have it here.
Oh, you do?
Yeah.
What is it?
Hold on, let me look for it.
Oh my.
Oh
It's
my
somewhere
gosh.
around here.
It's arctan. But, well, I mean, we did the, oh no.
Oh, those are the
it's
derivatives.
Arctan. Arctan. 1 over 3 arctan x over 3 plus c.
That's for arctangent, though. This one's a square root.
For real, you're looking at
Yeah,
Google
but
Images?
this is the same problem. The 9 over
Yeah.
dx
I need to take
over,
pictures for computer science.
the dx over.
Oh, it's right here. Wait, which one is it? Wait, can you go back?
Arc
What-
sine.
What are we doing?
This one, this one, this one.
No, that's arctan.
That has a square root.
Arc10 is plus.
Isn't that arc?
Arctangent has no square roots.
Can you
And
check
that.
I'm lost.
this? Is it this?
I'm guessing it's arcsine.
Yeah. So yeah. Okay. So there's no 1 over a. That's the part I always struggle with.
Oh, okay.
Thank you. So it would just be arc
Helpful.
sine
So on
of x over 3 plus c. Right?
screen, shut up.
Yeah, you do.
So yeah, I've done a bad job of memorizing them myself. So
You did
arctangent.
us too.
Yeah, arctangent. The arctangent one, if you have here, is going to be du over a squared plus x squared. There's no square roots. That's how you can tell the difference. If there's no square roots and it's a squared plus a squared, then this one's going to be 1 over a arc tangent of, that shouldn't have been an x, that should have been a u over a, right? Whereas for sine, right, if you do one for sine, you do the integral of du over the square root of a squared minus x squared, right? It follows this pattern. This would be equal to the arc sine of, dang it, I did it again, u over a plus c. Okay? So I'm bringing this up because, again, like, they might not look exactly like this. You know what I mean? So if you look at the problem we're about to do, notice the difference. What do you have in here? An x. So that's actually going to mess things up just a little bit. Also, notice that it's minus x squared, right? So I'm going to do a little bit of sign changing, and I might lose you along the way here, and that's going to be a little weird.
1 second, just go back real quick. Okay, wait. Okay, wait. Yeah, okay. Okay, there.
Take a picture.
Yeah.
Yeah.
No, I got it.
Okay. If anything, these two, if you really, really want to memorize them, put them on a flashcard and just practice them. Okay? It's like the whole thing of like knowing all the derivatives and all the antiderivatives of trig functions. These are 2 extra ones that if you want to have them in your pocket, it wouldn't hurt. But if you don't have them in your pocket, you just lose a point. And it's
I knew it.
and it's just 1 point.
Your groceries don't have pockets, nothing, so.
Okay, so for that one, over, it says du over the square root of a squared minus c over u squared is the same as the square root of 9 minus x squared. Why does it say that there?
Say it one more time.
Because, okay, that one has two, like, things to the second power inside of the square root.
Uh-huh.
And it's u over a, but the bottom doesn't have both of them for the square root of 2. But it's x over 3.
Okay.
Just because
I got you. I got you. I got you. So a squared is equal to 9.
And then u squared.
See that?
Yeah.
So now we
So that means that a is equal to 3. Does that make sense? Okay. And I can't do that over, I mean, and that's what we did over here. If you notice, a in this case was 8, right? I'm sorry, a squared was equal to 8. So a is equal to the square root of 8. That make sense?
Yeah.
Okay. All right, let's go back to this one. Now, here's the thing. I'm going to do a little bit of algebra mumbo jumbo, and it's going to look like crazy stuff. So, you ready? All right. This one's going to suck. Okay, so check this out. We have dx.
You need a vacation too, nothing. Let's just have a break period.
Nope. We can do that on summer. All right, check this out. When you factor things, usually our x squared term is positive, right? So here's what I'm going to do. I'm going to factor out a negative sign. So I'm going to put a negative in front of this thing, and inside I'm going to have here as x squared minus 8x. You okay with that? I'm switching the signs out so that way this will be easier to factor. I just don't like dealing with factoring a negative x squared. You can't. You can't just take out an x from the square root because it has a plus and a minus next to it, plus or minus. And that's going to mess it up. Now, this is the part where things get weird. This process of the whole, how do you complete the square? This is the thing, like, how do you know what to add, right? When you complete the square, this is always the process. You don't look at the number that's in front of the x squared. You look at the number in front of the x term. What's the number in front of the x term?
8.
What you want to do is always take half of that number and square it.
Oh, we did that.
So what's half of 8? 4. What's 4 squared? 4 squared. Squared. 4 squared is 16.
Oh.
So guess what I'm going to add? What am I going to add? 16. But in order to keep this balanced, I also have to what? Minus 16. So that way I'm not adding any number really to this problem, right? I add 16, I subtract 16. I'm not actually doing anything to this problem. But it makes it so I can do this. If I take a look at just this part right here and this part right here, can you guys see that that will factor? X squared minus 8x plus 16. That 16 is a magic number that helps us to factor this into a perfect square. What does this become? What are two numbers that will make this? X minus 4, x minus 4. And if you have trouble remembering that, it's just a technique, right? You either do the x method to factor or the box method to factor.
I just don't see you guys do that in your head. Like, for some reason, that just never worked out.
You want an easier trick? For this technique, Devin? What was half of negative 8?
Negative 4.
It'll always be that case. What is half of negative 6?
Oh, negative 3. Yeah, negative 3.
So when you complete the square, that number actually shows up in the factor.
Oh, okay, that makes sense. I just could never just go, oh, look at it and go, oh, that's x minus 2, x minus 4.
Yeah.
You know?
It's okay.
Never do
I was
it.
never gonna.
Yeah, no, it's just,
Okay,
that's a whole different thing.
Okay, I got it.
Okay, so check this out. You ready? That means that this thing right here, this right here, I can write as this. Okay? So I'm going to have here dx over the square root of negative. Parentheses in here, I'm going to have x minus 4 squared minus 16. You okay so far? Have I lost anybody? Be honest with me.
You lost me when you put the negative sign outside. Is that to cancel out the negative sign inside?
Yeah, I don't like having negatives in front of my x squared term because it's harder for me to factor. I didn't need to do this, but I don't know how to factor from here. So I factored out a negative sign, so that became positive x squared, and this became negative 8x.
Oh, I got you.
So then it'll be easier for me to factor. That's it. It's a weird algebra trick just so that we can deal with it. You don't necessarily have to do it. I've met people who can factor from here. I'm not one of those people.
Faster.
No, it's 3 times you do that.
Now check this out. This gets even weirder. Because you pointed out, right, Jasmine, that there's a negative sign in front now, yes? Guess what I'm going to do now? I'm going to put it back. So you know what that negative 16 is going to become? Yeah. You know what this whole parentheses thing is going to have in front of it? Uh-huh. So you ready for this? I redistribute that negative sign. We end up getting here dx over the square root of positive 16 minus x minus 4 squared.
Can't we factor that? Or
You can, but it will not help us. But you can. Very good observation. You could say that this will be 4 plus x minus 4 and then 4 minus x minus 4. You know what's crazy though? If you simplify that all out and you distribute everything back, you know what you end up back at? It's kind of neat, but we don't want to do that because this is a little bit more complicated, but it's very, very similar to du. Guys, stop talking so I don't have to talk over you. A squared minus u squared, where my a squared is the 16. See that? My u squared is this stuff. right? So if I wrote this out, I can say that a squared is equal to 16, which means a is equal to what?
4.
Good. My u squared is equal to x minus 4 squared, which means my u is equal to what?
X minus 4.
Which means du is equal to,
X minus.
no, dx.
Oh.
Yeah, the derivative.
Oh, you're just doing, okay.
Yeah. So, you ready? I just wrote all this down, but I now have my a, and I also have my u, and I can replace my dx with just what? So there's no extra fraction involved, yeah? Now, here's where it comes down to, do you memorize the antiderivative of this or not? This is going to be, and I did not remember it until now, that it's arc sine of what? U over a plus what? So you ready for this one? What's my answer for this whole problem right here? Arc sine of x minus 4, no squared.
No square over 4.
Oh yeah, that's
So then a 4 is what?
No, don't kill a puppy.
Alright.
You can't kill a puppy.
Mike,
Why?
I forgot about that.
Yeah, you can't cancel out those 4s because that 4 on the top has a minus x with it, yeah?
And it belongs to
Yeah, so it's a whole group, right? And that's my answer. See, here's the thing about these problems. What I really like about it is the answers always come out really clean looking. What I don't like about it is who the heck remembers to add 16 and subtract 16? And that's the part about math is you're not supposed to remember that step. You're supposed to understand that it follows this technique, right? So that number isn't always going to be 16. That number could sometimes be 9. It could sometimes be a really random number because it's always half of whatever numbers that's there, right?
Okay.
So that number was 8, half of 8 was 4, 4 squared is 16. Could you imagine if that number wasn't 8? What if that number was a decimal? Guess what it would have to do? Take half of that decimal and square it, and you still do the same technique. Now, when Devin was saying, like, how do you do that in your head? You still use that trick, and you just say, what's half of that decimal? That number will be the factor. Does that make sense?
Yeah.
So, like, if you had, like, for example, 3, what's half of 3?
1.5.
1.5, and then you're supposed to figure out how much to add, which is 1.5 squared is
3.25.
close, 2.25.
Damn it.
But here's the thing, when you factor 2.25, guess what goes inside? 1.5. Instead of actually sitting there going, what the heck factors into 2.25? You just go with the number that you got half of earlier, which is 1.5. Okay? So there are little techniques like that. Again, I wouldn't stress too much about these types of problems. I think the only time you'll ever see this is on your test that you're taking home later today. So there's that. But on the
stress, but you have homework on this.
But on your AP exam, I don't think you should stress on this type of problem. You come across a problem like this and you're like, crap, U substitution doesn't work. Just skip it, come back to it if you have time. Anita.
So when you factor, when you're completing the square, it has to be negative. I mean, like subtracting from each other.
Yeah.
If not, then it's like a different.
Yeah. So if this thing had came out to be 16 plus this square, I'm screwed. This is not an arc sine problem. Now, if it came out to be 16 plus this thing squared without the square root, I'd be like, oh, that's arctangent.
Okay.
So it's one of those things, like, you're hoping that it fits.
Okay.
And if it doesn't fit, then it's something else. And we just have to try something else.
We just have to know that. Okay.
Yeah.
Kind of like the derivatives.
Yes. Yes. Actually, yes.
The
Mhm.
anti-
Very good. Very good. All right. That's the completing the square technique. Again, this is like,
So that's the extra credit that I take a picture of? That you can't skip?
No, we already.
oh, we already went over that one. And also, you have to submit that before 7:50.
Pause. Time out. Where are we? Huh? We were supposed to submit that before 7:50.
Yeah.
In the morning.
Yeah.
We come here in the morning to
Morning.
do it.
AM.
Submit
Come
it.
here in his class. Yeah.
When did we look? Okay.
You talked about it yesterday?
You
were-
did.
And he went over it, but you weren't here.
I was here today.
No,
Yeah.
I meant like this today. We went over the problems he gave us.
Well, I mean, in order for me to submit at 7:50, I had to have been here yesterday. So whatever. It's fine. It's okay.
Wait, you had
What?
You
what?
have to
It's
come
okay.
in the morning
It's a
today.
Continue.
You have to come to
Okay,
the
Devin.
morning
Moving
today.
Problems aren't posted after school. Problems are posted at 7 a.m. Then you guys can't get up here till 7:30.
7 a.m.
Yeah.
Yeah, but you can't get in here until 7:30 because they don't open the
So you
gates
have to
until
race
7:30.
over here.
I don't even.
But you can.
That's all. It's all extra credit. So 7:30 every single day, that problem will be out there.
Oh, it's just a gotcha.
It's one problem. It should take you no more than 5 minutes to try. To try. 5 minutes to try. It's okay if it takes you more than 5 minutes to get it right, but I just want you to take 5 minutes to try, submit it, and then we'll go over it.
Okay. Let's say we're wrong. I'm not gonna.
At least you tried.
At least you tried.
You'll still get some points.
Oh, okay.
Some
How many points is each individual?
Make sure you give Adrian no points.
Probably got like 0.5.
Yeah, something like that.
Give Adrian no
What?
points.
It all adds up.
We probably got like 0.5.
Give Adrian no points.
Okay, so
I doubt it. 0.5 is like the full.
another technique. Yeah.
Oh, I
no,
love
you have
long
to do
division.
seven?
long division.
I like the one that Miss Chow taught us. That was fun.
Yeah, that one was fun.
Miss Chow, you
I'm
stressed me
sorry, I
out.
just love that. That's
All right.
my favorite math.
Oh, you didn't like it.
So check this out. Sometimes you'll come across integrals that look like this.
That was my favorite math. It was easy.
3x cubed plus 2x plus 5 over x squared plus 4 dx.
I'm not.
Use substitution for this one will screw you over.
Yeah. I got stuck on that on the circuit.
Yeah.
Like the X one, I was like, how do you
So sometimes use substitution might work.
Yeah.
And you always should try first, right? But check this out. If you do use substitution for this one, which I don't suggest you do yet, but if you did, if I have here u is equal to 3x cubed plus 2x plus 5, du would be equal to 9x squared plus 2. Now, there's no common factor here. There's no common anything that I could factor out so that I can get it to look like x squared plus 4. So u substitution fails in this case, right? Because that thing doesn't match with that, right? No way I can get this to look like x squared plus 4. Sometimes you'll have a common factor. Sometimes you'll have something that you do to rewrite it. But this case, it doesn't. Now, the way we fix this is we try something else. Usually with integrals, one thing that you want to try is to rewrite it into a form that might be easier to, yeah, so if we can separate it out. Now, the technique for separating fractions or rational expressions like this is long division. You might not remember long division, but long division looks something like this. If you have a fraction of a polynomial over another polynomial, you can divide one into the other one. Does this look familiar?
Yeah, Miss Chow.
This technique is not calculus. It's strictly algebra. But it's a nice algebra technique to help you to do the calculus. Watch this. How do I get x squared to match up with 3x cubed? You multiply by 3x. 3x times x squared will give me 3x cubed. Uh-oh. 3x times x squared is going to give me,
Should be negative.
Oh, I hate this.
what?
Oh, wait, never mind.
Wait, can you redo that again?
Never mind.
Yeah.
Times
Because
what?
I thought they had done.
Isn't it the whole thing? It's 3x times 4.
Yeah.
Miss Cal taught us when we were doing synthesis, it was a whole
Stop,
thing.
stop, stop, stop. What are you guys having a question on? Jasmine?
When you do long division, isn't it the whole thing on the outside divided by the whole thing on the inside?
Yeah?
So then why would you just do the x squared? Where does the 4 go?
I'm not done yet.
Oh,
What's 3 times 4?
12.
Okay. I was
12 what?
12x.
X.
Yeah, yeah.
Okay, there we go.
Also, you're still not done. Because after that, what do you do with long division?
Bring down the 5.
No.
Plus 2.
No. What do you do with this whole thing?
You subtract.
There you go.
Oh.
So the 3x cubed cancels out. You have 2x minus 12x, which would give me
Wait, sorry.
negative 10x. Then you bring down the 5. Okay, go ahead.
Why is the 3x on? How about 2x?
Yeah, that's what I was.
I'm sorry. Where do you want me to write it?
Oh, because isn't there an order to it? Like you have to write it there.
You can write it anywhere you want.
Yeah, you can write it anywhere.
Okay, never mind.
It's
No, but doesn't it have to be there?
No.
Because you have it aligned with that.
I mean, you
Like
have
that's
to
where it
have
ends, so that's where you put it because you cover all of that.
real quick. How do you do 36 divided by 53,485?
You use a calculator.
Well, if you did it by long division, how many times does 36 go into 5?
1.
0 times.
0. How many times does 36 go into 53?
Oh, 53.
Now this is the part where you guys are arguing about. Where should I put that 1?
Oh, top of the 3.
Does it really matter?
No.
Yes. Yes, it does. Because you have it in the
Because you're still
order.
getting the same
I
answer.
thought that it was like.
My thing still stands. It's yeah. If you prefer it over that, put it over that. If you don't care, it's still going to come out the same way. Because if I put that 1 there, it's not any different from me putting the 1 here. It hurts a little bit to put that 1 there. I'm not going to lie. Anita.
Wait, so with long division, you're just using the square, the x squared to define how it equals
The first term, yeah. The easiest shortcut was to try to get this to match with this. And then, yeah. And then when you subtract, you try to do it again. But this time you try to get this to match up with this. You're always trying to get it to match up with the front one.
Okay.
So how do I get this to match up with negative 10x from x squared? And the answer is you can't, because that's now your remainder. So here's the thing. Doing long division, I can't go any further, right? This is x squared, this is just x, right?
No.
So if I was looking at 3x cubed plus 2x plus 5 over x squared plus 4, this whole thing is actually the same thing as 3x, ready? Plus negative 10x plus 5 over what?
X squared plus
Squared, huh?
X squared. What the? No one saw that. X squared plus 4. So I can replace this whole thing with this. Now you'll say, knock me, is that actually any better? A little bit better. You know why? The 3x can now be integrated. Because now I can write this as the integral of 3x dx. Would you agree? Plus, and then do the integral of negative 10x plus 5 over x squared plus 4 dx on its own. Now you'll say, Donkey, that doesn't look any better, and I agree with you, that doesn't. But at least I can do this now. Can I not? This is easy right there, isn't it, that I have boxed? I can do that piece of cake. Now I'm going to look at this fraction and be like, yo, how do I deal with this? U substitution, but before I even do U substitution, you know what you can do with fractions that have a plus sign between them? You can separate those. So I can write this as plus the integral of negative 10x over x squared plus 4 dx plus the integral of 5 over x squared plus 4 dx. And you'll say, knock me, is that actually any better? And I'll say, stop being so negative. It actually is a little bit better. Because here's the thing. I don't know if you see this or not, but you can do a U substitution here.
Yes.
You can let u equal to x squared plus 4, which means du is equal to 2x dx, right? Move the 2x over, you end up with du over 2x is equal to dx. Yeah? So you ready for all this? This thing right here? I'm going to move the negative 10 to the front just to make this a little bit easier to see. Okay? All right, no, don't do that yet. Not you're going to confuse people. So I have negative 10x in the bottom here. Instead of x squared plus 4, what am I going to replace that with? With just a u, yeah? Instead of dx, I'm going to replace that with what? Let's do that in red so we can see that a little bit better. So instead of dx, I'm going to have here du over 2x. What happens with the x's? They cancel out. And what happens with the negative 10 and the 2? Yeah. Negative what? Negative 5. I'm going to put that in the front. You okay with that? Negative 5 in front. I'm left with the integral of du over u. And isn't that an easy integral to deal with? Because what is that, by the way? So ln. Yeah, negative 5 ln of absolute value of u. But what's u? That x squared plus 4. So that's pretty much done as well, isn't it?
Wow. No wonder there was an ln in the answer for that big polynomial.
Now, we got to figure out this one. Crud. Does this one look doable?
Yes. Oh, actually, no, because
It's doable.
Wait, for the other one, so when you simplify, right, it's going to be negative 5 over u. Why do you go to the 5 on the other side if it's not with the u? With the du?
So if I simplified first, it should have came out to the integral of negative 5 du over u.
Oh, you're multiplying.
I put the negative 5 out in front because I know what the integral of du over u is, right? So that's just a coefficient. Put the coefficient in front, deal with it later. It's the same thing as like, what's the integral of 3x dx? I think it's easier to just deal with the x dx part and just put the 3 in front and deal with it later. We just got into the habit of doing it without actually writing it out. You know what I mean? So we write out 3x squared over 2. You know what I mean? Same thing that's going on here. It's just a little bit of flavor. All right. Did anyone figure out what does that look like? Arctangent. Wow. I'm sorry. That's just you're so much better than I am at this. 17-year-old me. 17-year-old me would have looked at that and just be like, nope.
Yep.
Can we see how 17-year-old you look?
Oh yeah, I was gonna show you pictures.
Oh yes, I want.
You still haven't shown us your skateboard. Right.
It's in the car.
I even asked you. Oh wait, I haven't asked you after tutoring after that one time.
You could bring it.
What do you mean? It's always in the car.
So
Oh, I was supposed to bring it up here?
That
No.
one day you didn't have in your car.
Yeah, that
I
one day
asked
we
you.
all came and
Oh
you
my
were like,
You should
I've
pop a
seen it,
wheelie
not
after
me.
school.
yes.
Okay.
Do tricks?
Yeah. I'm not gonna do it in my Jordans though.
In Ollie?
For real?
In Ollie?
I can ollie.
Oh.
I think I can still ollie. All right. So you know that this, guys, focus, focus. So we have here a is equal to 2. Yes. Right. That's the only catch to this thing, right? So if I actually integrate this, this is going to be plus. They have a coefficient of 5. I'm just going to bring that in front. Is that okay?
Yeah.
Multiplied by, since this is arctangent, it's 1 over 2 times the arc tangent. Yeah, I think that's okay, right?
Yeah, yeah.
One, arctangent of x over 2. Why is it not 4?
Because it's the square
Because
root of
it's
Yeah. Yep. So that one is actually the easiest of the bunch, isn't it?
Yeah.
No? Yeah, for you guys. Not for me. Like I said, I would have noped this problem so long ago. But that's it. That last part's done over there. This one over here we can easily calculate. And the part in front we can also easily calculate. What's the integral of 3x? Oh, I just did it over here on accident. 3x squared over 2, right?
How do you do something like that on accident?
I don't know. I don't even know how did I know to put 3? Anyways. So what does this become, by the way?
There earlier.
This is going to become -5, yes? ln of u, but u in this case was x squared plus 4, yeah? Plus 5 over 2 arc tangent of x over 2. And in front we had 3x squared over 2. All of this, of course, needs a what at the end of this? Plus c.
Wow, I like that. So you know how there was a -5 from the 10, and then how there's a 5 from over the 5? Couldn't those two just get canceled out?
No, because you're looking at this -5 and this +5. Is that what you're saying we can cancel out? Could you cancel out -5x squared plus 5x? Could you cancel out those 5s? Why not?
Because they're different variables.
Yeah. Make sense? So, crazy thing. Before I say it, go ahead, man.
I was gonna say, is it okay if I'm writing like arctans and
Yes. So, that's actually another important thing I should
Yeah,
bring
I
up.
was gonna ask that one time and I was like,
On the AP exam, they do both to mess with you. So if you see arctan, you'll probably have no trouble with that because we've been writing arctangent a lot. In the AP exam, sometimes they like to write it as tan to the -1.
Yeah, I've been writing it like that this whole time. So like I wanted to.
I started, but then I changed it because you've been writing art.
Go both,
Yeah.
right? It
I'm
will.
very used to that notation.
Yeah.
The bottom one.
Yeah. Me too, but I want you to get used to both. Okay? So if you're comfortable with that, write that one down, and then you get, absorb the comfortableness as I write it out this way. You want to try one?
Yes,
Yeah.
please.
All right.
Once we get it wrong, but whatever.
Now here's the thing. For this problem, don't worry about all these little techniques here, right? For this problem, the bigger thing I wanted you to grasp was the fact that I could do long division and rewrite my problem. That's the overall thing I need you to see, is using long division to rewrite it into something that we can try to do. So for this one, do you want one that sucks?
Sorry.
How bad
No,
is
to
it?
be honest.
Okay.
You don't want one that sucks?
It's been a tough day. Now let's
Okay, I think you guys can do this one.
Can we do it with long division?
Well, yeah.
Then just go ahead and do it.
All right, let's try this one with long division here, and I want you to try this. So let's say I have here the integral of x cubed plus 3x squared plus 8x plus 19
Oh, that's 3.
That's a lot of
divided by x squared plus 5 dx. This one's a little harder.
Oh.
No, actually, no.
I
No.
think it's
No.
becoming more and more, yeah.
Yeah, I think you guys can do this. I have faith.
That's good.
While you guys do that. Wow, how'd you know?
Because you always say that.
I always say that?
Yeah.
She would always take
Wait.
attendance later.
Yeah.
And it works out.
We found a
You're always
teacher's
like, oh, I need to do
attendance sheet
attendance.
yesterday.
You found a what at the what?
We
Don't
found the
forget to mark
teacher's
Devin
attendance
absent.
sheet at the stairs yesterday, and they're from this building, but they were in the D building. On the floor. Stomped by many students.
Hmm.
I turned him in like super late though. I was being nice. I was being Samaritan.
Oh, you picked it up and returned it?
Yeah,
How nice of you.
I know.
Okay.
I forgot you long division. Oh, that's
You do the long division.
You want the screen back to the long division?
Yeah.
Alright, give me that. You guys have this problem written down or?
Yeah.
Copying it down just sounds too mature already.
Wait,
I'm doing it that way.
man, this thing didn't even
I don't know where to start.
long division.
Alright, I got. You ready? You got it written down? That way I can scroll up so you can have the example for the long division.
Yes.
I just got X. for
I
my
got
first
X.
step.
I got X too.
Alright,
Me too.
That's good.
Squared plus
If you all got X, I got X too.
Alright, let me scroll
Nothing else you could do.
If Lala gets X, we all got X.
here. Anyway. There's the long division.
No, I just wanna make sure.
The only thing that's getting me is the
Wanna make
3x
sure.
squared.
How come your
Wait a minute.
3x and
See,
5x
that's a-
became just x? There's an x squared there.
You'll still include that, it's not like two.
You know what, so x times 5 is 5x, isn't it? Why don't you write it here and line it up with the white term?
Yeah, and what do you do with this? I forgot what you do with that. You just bring it down? Oh.
Wait, you do plus 5X?
What?
Okay, that makes so much sense.
So what?
So when you do long division, hopefully you line it up with like terms.
Oh.
So wait, it'll be.
That makes so much
wait.
more sense. And you just bring down that 3x squared. And then you continue the. Okay, that makes so much more sense.
Wait, I'm gonna.
I got X.
Okay.
I have X. So X.
So,
We bring down the we bring down the 3x squared and then
okay,
we
so
also
that
bring
was 5x
down.
and then you find out that it's
Is it
because
3x
like
as well?
the like term.
Oh, you did?
Yeah, the 3x squared and the 3x, right?
Yeah.
So you see how this, obviously, x implies like 5x, but you can't, how do you say,
It's like
subtract it from 3x squared, so you have to subtract it with the like term. And you just
Oh.
bring the 3x squared down.
It's like a game of Tetris.
Yeah.
I don't know.
It's
Well,
minus
I
5x,
know.
right?
So,
Yeah.
Anita, you have 3x squared plus 3x plus 19.
Plus 13x plus 9. Where'd you get 19 from?
I thought you subtracted, you don't subtract it?
That's what did I
You
do?
just subtract it. That's why you get the 3x.
Yeah, you're right. You were subtracting. Never mind. I added.
2 times 5, 15.
Alright, that's the farthest I'm gonna make it. I give up.
Don't give up.
No, it's fast.
19 minus
Good.
15,
Yes,
that's 4.
Yeah, minus 3x.
Okay, this is what I got.
Plus.
Isn't it 3?
Makmi, is this right?
I think it's 3x.
Wait, 3x or 3?
We got X
Is
plus
this right?
Yeah,
So
x
you
plus
put that over
With the
that?
remainder of 3X.
I think so.
Okay.
Yep.
Yay, I got it right.
Wait, 3x plus 4.
Yeah.
Yeah,
Because
3x plus 4, yeah.
the 5 and 8, so the answer would be 5x. And so x plus
Okay, now you're gonna do the
Yes.
stupid integral
It's
crap.
because 3
Beautifully
times
done.
5 is 15, and then
See what I mean?
you
How you
combine
shut
like
down and
terms,
give
so
up?
19 minus 15 would be 4.
No. 8x.
You don't have to opt.
You
I'm
need to
getting
go
a
like-
bring for 3x down.
Come on, stir.
Did you and stuff to make it do work?
Okay, after you put the plus 3,
Do work.
it's 3x squared and then what else?
Does that work?
Hey, can you separate it?
No?
This
Minus
x
I got
plus,
nothing else.
0 minus 15,
instead of
right?
it being like you could
Get a
put
whip.
x and then plus integral 3.
Take it back to the old days. Do your work.
Oh my god.
That's a lot of integral.
Yeah, that's me.
That's
Over the quotient.
plus 3.
Wait, sorry.
3x over x squared plus 3.
I'm gonna just do it like that. 3x over.
I think you can separate. I don't know.
Yeah, you can.
Yeah, then you change the sign.
It's negative.
What do I do?
Yeah, should be negative. Okay, thank you.
Wait, Nita, were we right?
Yeah.
Not me.
Yeah,
Can
I
you
just
do
did it
this?
with my
Okay, let me come over
mouth.
here
Yeah.
first.
Okay. You did this, right?
The remainder is 3x
Yeah. So I'll
Minus
just
six.
is this the
minus 6?
Yeah.
Wait,
No,
I'm
that's
got
not
4.
Wait.
Minus
Yeah.
4? Oh, no,
Plus
no,
four.
no,
No,
I
plus
didn't-
4.
Wait, no, no, no.
Plus
Plus
Wait.
four.
Yes, yeah, yeah, yeah.
So they're both right.
So the
They're both
remainder.
R10.
It's
So we
19.
can still do use of
19 minus 19 minus.
Okay, R10 now.
No,
Because
because
it's
it's
an
not
X.
X. You use
I
of
was
this
like,
R10.
where'd you get that from?
Honestly, I checked with you. Like I'm wrong. Honestly,
Well,
that's the
you
funniest
use,
I'm making
Oh,
out
that
of.
is compressed. Okay.
For the one that we have to use, do use of substitution, what's yours?
It's not depressed.
It's not decompressed.
Is it 3x or x?
I don't know. We can try.
I'm kinda lazy, like,
We can
I
try
wanna-
3x
This seems-
squared
this
plus
looks
5 and see
like-
if it cancels out with 3x.
This looks like-
I'll try.
It's x plus 3.
It's,
X 3x plus 4 over.
wait, it's x plus 3.
Yeah, if you cancel, so it's x squared plus 5 is for you.
Wait, whoa, 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 whoa.
3x plus 4. I would separate that.
Whoa.
I can?
Okay.
You do
Hold on.
3x over stuff plus.
And then 3x plus 4 over x squared plus 5?
Yeah.
Okay. Make it work.
We satisfaction and x's cancel out.
I know.
And acting like.
Okay, I got 3 over 2 ln x squared plus 5.
So 3
I
and
said
then.
3.
3 over 2.
3 over 2, huh?
Because, look,
Oh, okay, yeah.
that only the x's cancel out.
Okay.
Hey, isn't it integral of 3 to 0?
Huh?
The antiderivative.
Right, 0, yeah.
It's 3x. That's what it is.
Yeah.
3x. Of 3.
For the first integral, the x plus 3.
Yeah, it's x squared over 2 plus 3x. That's not 3, right?
For 3?
Yeah, 3 is 3x. That's the
Equal
derivative of 3 is
5.
nothing.
So
The
a
answer
is
is
gonna
nothing.
equal
Inside
square
derivative,
root
isn't it
of
just
5?
3x?
Yeah.
Over 1.
So then it's 3.
Hold on. Whoa, whoa.
Would it be 1 over 2.5?
What?
It's not a, right?
Yeah.
It'd be 1 over 2.5.
Because you have to do that 4 times. And then we have plus 4, 4 times, and then 1 over square root of 5 r 10
I'm so slow. I'm so slow.
Me too.
X squared over 2. Okay.
Oh, and then you'll just do 4 over square root of 5. That's gonna simplify 4 over square root of 5. Not me, is this right?
So 4 over 2.5 essentially. It's x over a, right?
Plus 3.
Okay, yeah, this works out. Why am I blinking on the
Hey, I got
integral
it
of x
right.
plus
I'm honestly
Well,
blanking out.
it looks right.
It looks right?
It looks
oh
right.
Oh my gosh. Okay.
Wait, I blinked
I
out
don't
on
know.
the.
This should be right. It better be
I think
right.
it's right.
It's
Oh,
right.
okay.
I'm at d over 2x.
Ooh, I need food now.
This is what I have. Alright, so I did. Right, and.
Oh, when you, this is after you do the division?
Cancel out.
It should be 4 of that, because you can separate the x plus 3.
Lila. Starting with this.
Damn it.
Oh, we're still gonna get out of the fact.
Okay. So,
Okay.
there, and then the ball's gonna be my. Would you like to see a video?
Oh, okay.
Let me show you.
If you do that now, you can split all of these, which is an integral of x dx. So, the integral of x dx plus you can split this plus integral
Yeah. It's a negative.
integral 3 dx. And then plus
This is.
the integral of 3x over x squared plus 5.
I was looking at the wrong problem.
I ran out of space. No.
Over x squared plus 5.
I would say,
Oh,
how many years possible? I just contact us there.
That form.
Well, because I'm not that tall. I'm not Superman. Oh, well.
Not yet.
Sucks.
I ran out of space. It's like I'll just cram down like down here.
You know, what you can do is turn your paper over and write from the top of the next page over.
It's so painful.
You know, that's how paper works. It's okay. You can work from one side to the next.
It's so I have to like write and then be like, okay, what am I writing? And then just keep on going back and forth.
Yeah, I got that.
Well, it's good. Can I check?
Because whenever you have one of those.
And if it's not, you can always check here, but in this case, you use that.
I want to read, sorry.
2x.
How come this is not there?
You're right there too.
Now you're just gonna substitute integral.
We have to figure it out.
Oh, you already wrote it down?
I simplify. If it's 4 times 1. Oh, okay.
I'm like halfway there.
Right.
No, yeah, you're right. You're right.
Okay. Alright. I got 3x for the answer. So, I'm gonna do that.
Since it's gonna be 5 times x, 5x, it's minus 3 plus 5x. But if you subtract 5x from here, the terms are not like
1 over 5.
x squared doesn't work out, you know? So instead you're gonna do minus 5x. So you're gonna like, kind of like a game of Tetris.
Then after this,
You have to align it, right? So you're gonna do 0, yeah, so I'm gonna bring all this down.
And then this is just gonna equal arctan, so your a is squared
And do x squared plus 3. Does that make sense? Okay?
oh, but no, Jasmine, you can't.
Okay, I think I got the answer.
5 times 3 is 15.
Let me go take a look.
It doesn't align here, so just move it over minus 3.
There might be a couple of errors, I'm not gonna lie. Maybe I missed it in something.
So 4,
Bring it down.
4 times, 3 is not 4 times 4. 4
There's,
times
that is your remainder because x squared is
1 over a.
what you're dividing by, and 3x doesn't have x squared. So
So-
cancel out. So your answer
Arctan.
Can't do,
is
wait,
gonna be
can't do
I
the
love.
substitution because
x
you'll notice
plus 3
Something
you
plus
have 2x here,
your
you have only a 4 there.
Over a, which
You
is
added
Oh,
x in there.
my bad.
So U substitution doesn't work in this case.
over your what you're dividing
I
by.
always wanted it to work, but it doesn't work because there's no x.
How come you managed to do really neat
Hopefully it
handwriting?
looks more like this one.
Is it from the
X
first?
squared plus
I don't
number.
know.
No way.
Okay, so now you're gonna integrate this. Just you're gonna divide this into 4 parts. It's really simple. X dx. So it's 3 addition terms.
I know.
So it's x plus 3 plus this. So
You don't
you
need the
can do
parentheses around this?
integral of x plus the integral of 3 plus the integral of
Bro,
3x
it didn't take long, did it?
3x. But other than that,
plus
what's the integral of 3?
the integral of 4
Thank you.
Integral of
Why
x
is
is
it
x
so
squared
long?
too.
Right.
You're
you separate like this fraction. So your answer is gonna be. Isn't that cute arrow?
Well, yeah. A squared is 5, so it's a squared is
Yes.
not.
Then we do 1 half squared.
A squared is 5. Okay, let me see.
3x
Square root both.
plus.
So a
Or
square root
times 1 over your A.
Okay, here you can do u substitution.
I really stopped
Over
saying
your
this.
a.
Which is gonna be square root of 5.
U is equal to.
I really stopped saying
And
this.
obviously when before times
Okay,
1 over
so
square root of 5 is 1 over
X
square root of 5.
dx.
How do you get from
dx.
here to here?
Honestly, I had 75%
So,
answer.
Integral.
but you can
Why you
do
lying?
No, I did. I had 75%.
Don't lie.
I had.
No, like, there's
It's
no
dx over x squared plus
Times
5
d.
Yeah, no, I
is
did.
equal to
I just wasn't
the
gonna do it.
arctangent of
You're
dx
left with
over
Then don't lie,
x squared plus a
derivative
squared.
2.
Can you put your hand back
A
on the
squared
slide,
is
please?
So you
Oh,
have
Looking like a
So your
homer.
a is going to be square root of 5.
Oh, really?
Yeah.
uh,
Over
and
here.
then
So a is.
Talking about the
Now you see you're walking into the brush for a reason.
Bam. So don't add the secant because it's gonna be a
That's the
She
part
don't want
that's
you no more. She got a
So
boyfriend.
you
She's
can
like,
use
"Ooh."
arctangent or you don't know it.
Yeah.
Turn around.
And as
So
soon
get
as I
those notes.
I wouldn't know it.
Yeah,
I
I
wasn't in the
wait
same
for your
order.
answer.
I would have just been like,
then that arrow's in the way. I don't know how to
What?
fix that.
Yeah.
Oh, I have an idea.
you
You're
don't have
rocking your
time
chair
to
face
do
this way
it,
for a reason.
but I know.
Oh, really? Because that's not your seat. Your
I
seat
knew this was 4,
is
but
up
I
here.
don't know
You
why.
why
Wait,
worry
but
about
then I
me?
have
You're my
to drag that
business.
out.
Don't
Same
do
person
it.
that's ready to
Don't
read
do
as
that.
well.
Get out of my
Okay,
business.
we'll figure it out.
What is it?
Focus
Why
on that
is it
AP
just
lit
4?
grade.
Because I just
Okay?
put 4 in there.
What's your grade?
None of your business.
What is your
Don't you have a D?
None of your hell no. None of your
I like
business.
straight.
Don't you have?
Hey, what'd you get on the test?
We have the same
So you
grade.
still have that struggle with the coefficient rule.
We have a
Okay,
C.
so then you're gonna do. This is gonna be equal to
I gotta see.
It's the same thing as 4 times
I got a.
arctan. If you recognize the pattern.
Here,
So
I'm
A is gonna be.
looking at
Okay, so your a squared is equal to 5.
that's going to be the arctangent.
I'm 1% away from
Which is the
it.
coefficient.
A squared is equal to 5. What's half of 5?
du is not equal to 4.
No, but is it cheese like is it like Italian cheese?
Yes.
It's like the one that's in the circle. You said.
But then once you take
Or you can just do
so
root
negative
5.
4, right?
Sorry.
That's what you have to do.
I sound like a teacher.
No, Provolone is not the.
Oh,
That's not what I'm talking about. I don't like Provolone.
Because you're half to. Or you're. What's half of 5?
I don't know why you have no.
2.5?
Yeah, it's really hard.
That's not the square root.
Okay, not the answer because I
Oh, it's not. Wait, it looks like.
Like coefficient, so when you do the integral,
Not
you
that
have
way,
this
but-
coefficient like numbers that are multiplying with your function. So you can pull it out and deal with it later.
Okay.
It's like with derivatives. You have
Oh, yeah, du
3x
over, yeah.
squared, right? What's the derivative of x squared?
You're
It's 2x.
And I
Then your answer is
Okay.
3 times 2.
Oh, I have to rewrite my paper now. Okay. Yeah, you're right. We can just do
I think that's
root
4 is
5. I
like
tried
the
to.
coefficient. But you pull it from like an integral.
Okay.
Okay.
Root 5.
Only works though if it's
Then-
coefficient. It doesn't work if it's plus 4.
Arctan we can write over here is gonna be.
I somehow still feel like I got it wrong now.
Oh, I just.
What's
That's,
X?
we're not gonna come wrong.
You're close. You're just missing a 4.
Oh, I have to
Mr. Naga?
multiply that with that?
Yeah. Yeah.
Oh, so then it would be 4
So
over.
for the arctangent, you're multiplying by 4, right? In the
Yes.
beginning? What's the notation for that? Like if there's a formula?
It's just
No.
the coefficient. There's no-
Coefficient,
Yeah,
okay.
so it would just be in front of it.
Oh, okay.
Can we do another one?
It was fun. I want to do another one.
If it wasn't,
Yeah, it's on your test.
A whole number
It's the
coefficient.
Bruh, okay.
Okay.
Did you have to?
I'm able to do it by myself.
Notation is
Say it one more time.
Did you take off something that's
is
not
C5
coefficient?
No.
times
do it.
1 over
Yes.
A.
Coefficient, that's the thing. The coefficient rule is only for coefficients. So if you have any coefficient times any function dx, right? When you're doing that integral, you can take that coefficient out and deal with the integral on its own. Right?
X over A, right?
Does that make sense?
Yeah.
All right. Hopefully that makes sense.
Oh, hold up.
Wait, no.
All right.
No, wait.
Arctan is x over a?
What's up?
Next to arctan is x over a? Okay, so
1 over A, which is gonna
Not
be
X
1
squared
over
over
I need to start learning more.
I thought it was 2 over there.
Is you over?
Well, if there's more stuff with the but our u in this case is just x.
Yeah, I have a video.
Sometimes your u would be x plus 3 quantity squared, or x minus 3 quantity squared. In our case, it's just x squared.
I thought it was x squared plus 5.
No, man, but I'm not bad. I'm not bad.
Yeah, it's x squared plus 5, but the x squared, the squared,
Oh, you're u in x squared plus. Oh, okay.
So
I get
okay,
it.
let's do it one step at a time. So
That's handy.
so normally that's the arc tangent of x. Yeah? Yes? Right? You okay so far?
I guess.
The part that we can mix up or start adding in there is this number is your a. Yeah? So sometimes you can change it and rewrite that as dx over x squared plus 5. That just changes the a value, right? Which is going to be 1 over the square root of 5 arc tangent x over square root of 5. Yeah? The part that you're mixing it up with is sometimes you can mess with the x term. And when you mess with the x term, that's where u changes. So it is x plus 5 squared plus 5. That now would change this, right? So this is still going to be 1 over the square root of 5 arc tangent, but now this will be x plus 5 over square root of 5.
Oh, hold up.
That's a different problem.
Oh, okay.
Does that make sense? Like
I thought
that stuff squared. That's what u squared represents. Is like it's not always just x squared. It could be x plus 5, x minus 5, quantity squared. And that's when you mess with that top part.
Okay. So I'll see once you solve it where I went wrong.
All right. I don't think you went wrong. I think you got the answer.
Because I was asking Lila.
Okay. So I'm gonna shortcut this and go a little faster because I took way more time on this problem today. All right. So if you do the long division here,
Oh, yeah.
if you do the long division here, thank you. Right? If we do the long division here, we end up with x squared plus 5 dividing into x cubed plus 3x squared plus 8x plus 19. Hopefully you saw that you just need an x here to multiply with x squared to get x cubed. But then you might have seen that x times 5 will give you plus 5x. You can't write that here. I mean, you can, but you can't combine those two because they're not like terms, right? So that was the first issue that we come across. That right there needs to be moved to here. After that, we then make sure we know that we're subtracting this whole thing, yes? So that's going to cancel out. This is going to become a negative 5x, right? And when you combine this, this will be 3x squared plus 3x, and then you bring down the 19. Yeah? Get the x squared to match up with 3x squared. We're going to do a plus 3 there. 3x squared, 3 times 5 is going to give me plus 15. Am I doing okay so far?
Yeah.
Subtract that whole thing. The 3x just comes down, so we have a positive 3x plus 4 as our remainder. Yes?
Yep.
So this whole thing is going to be rewritten as the integral of x plus 3. I can do that on its own. That's fairly easy, isn't it? Plus the integral of 3x plus 4 over x squared plus 5 dx. I would split this up. This one's already done. Yeah? This one I would get split into two problems, which would be the integral of 3x over x squared plus 5 dx plus 4 over x squared plus 5 dx. Okay? This one is a u substitution problem just because I have a derivative of another function there. This one is not a u substitution problem because that is not the derivative of this. This one you have to be able to know that this is a what type of function? Arctangent problem. Yeah? So you would do u substitution for this one. This would come out to be something. I think it's like 3 over 2.
3 over 2 ln of x squared plus 5.
I like it. So that's what that should become. I'm not doing the work there, so hopefully that's right. This x right here should be x squared over 2. This 3 right there should be 3x. There's a plus right there. And this last one over here should be plus. Yeah, it should have been a plus, not a minus. I saw some of you guys writing -4 over there. That should be a plus 4 over the square root of 5, because that's what a is, arc tangent of x over the square root of 5 plus c. And that should be your answer.
Then I got that part wrong.
Is it okay?
X
double check that real quick.
So basically, at the very last step, it's just the x, not the a value too, right?
Yes. Now, if this had been x minus 3 quantity squared, I would write that as x minus 3 over. So just be careful with that. Well, that's an interesting problem.
Is that our test?
Mm-hmm.
Oh, it's 1 page?
8 problems. Okay. I know this sounds weird, but I'm going to start a new section.
Okay.
Okay? So, this is just extra techniques. Again, like, do or don't them. Like, it's not a big deal if you remember them, but it's nice to have that in your pocket now, right? All right. Let's go on to Unit 7.
No. No, Monica said this was the hardest unit.
Oh.
No.
Devin.
No.
She did say it's one of the
I thought we
hardest
had
units.
time. Oh.
We're not at the hardest unit yet.
She said this is the one that goes like all the
I like this one.
whatever.
And you can tell with the title. Look at how long it is.
Right, connecting
Connecting
position,
position,
velocity,
velocity,
acceleration.
Oh,
acceleration.
not all of that.
What section?
I thought we were done with
I didn't have time
velocity.
for all this.
This is easy. Don't worry.
Is this a new unit or a new
No,
section?
this is-
New unit.
He says it's easy, guys.
Oh, so this is 7.1?
Oh, yeah, I should do that, huh?
You
Yeah.
said it's gonna be easy to
That.
try.
Actually, also says it's right on here, and it has to be on the top. I can't put it on the next line.
Okay, so this is nothing different. You already know about position, velocity, acceleration. We learned this already. You remember?
Yeah.
Velocity just ended up being a derivative of position, right? If you have position on a chart, you can actually calculate velocity at a specific time if you know the derivative of that position, right? And at the same time, you take the derivative of velocity, you'll find out acceleration, okay? So you already know this. Now, what we need to do now is make the connection between the two. Yeah? It's not that bad. It's not that bad. So here's the thing. In the past, I always gave you the position function. From the position function, you just took the derivative and you were able to find out velocity. Does that make sense? Because you took the derivative, we could get there. And then if I asked you for acceleration, you just took the derivative of velocity and you got to acceleration. Yes?
Are we going backwards this time?
Yes. That's strictly it. That's the only connection now. Because if you remember, integrals are just what?
Going forward. Going back.
Yeah, the antiderivative. Yes? So,
We're starting with acceleration.
so we could, but we'll make it a little bit easier. What if I had started at velocity? Now, if I start at velocity, I take the derivative of velocity, I can still get acceleration. Yes? But if I take the integral of velocity, I can end up back at position. But here's the problem with this. It doesn't actually tell me the position function, but it will tell me the total distance something traveled. So hold on to that thought real quick. I know that sounds weird. So check this out. With derivatives, this one was more straightforward. If you had a position function, right? Take the derivative of the position function, what do we get? The velocity function, yes? It was actually the function that told you what the velocity is, okay? And if I took the derivative of that velocity function, what do I end up with? Acceleration. Again, the function that tells you what the acceleration is at a particular time. That's the part that's kind of like, it's exactly what that is, yeah? Now, here's where it gets a little bit modded. It's a little bit different, right? Not exactly the same, okay? So let me see here if I can get this correctly for you. When you start dealing with integrals, it's a little bit different, If I give you a velocity function and I asked you to calculate the integral from a to b of that velocity, this doesn't actually necessarily, that's a lot of words, this doesn't necessarily give you the position function. What this actually does is it tells you, right, the displacement. Right, the displacement, or if you want to say the net distance traveled. right? So like, for example, if he goes forward 3 and then goes back 2, the furthest this person traveled was 1. Does that make sense?
Yeah.
So the integral of a velocity from A to B tells you the total displacement. So if I go forward 5 and I go back 4, the total displacement should only be 1, right? So that's what the integral tells you. It doesn't tell you the position function. It tells you the total displacement from A to B, from where you start to where you finish. Does that make sense? Yeah? Okay. So that's the only real difference here. I can't actually get you exactly where he is, but I can tell you exactly his or her displacement from A to B. Does that make sense? So it doesn't work perfectly backwards, but you could actually find it. There is some tricks to do it, and it involves solving for C, and we'll get there eventually, but that's that one right there.
So if we ever get it like in this form and we're trying to solve for position, we would just do the antiderivative like that.
Yeah, okay, so this will be the displacement, and if you're looking for the exact position, there is an equation. I'm going to show you it right now. So if I was looking for the position of it at a particular time, right? God, okay, so here's the thing. If you know that the integral from A to B of velocity, right, is going to give you the displacement. The connection to this is that this is technically equal to the position at time of B minus the position at time of A. Yeah. Technically, right? But I wouldn't say this was the best way to write it. I'd say the best way to write it would be this. You ready? It would be S of T of B is equal to the position of where they start plus the integral from A to B of V of T dt. I'd say this one right here, this one tells you the position at B. Does that make sense? So, Anita?
If it was the position at A, be the other way around, right?
If it was the position at A, that's where you start, and the math is a little bit trickier. It would be S of T of B minus this.
Okay.
But we'll worry about that later. But that,
Then for the interval, like this is to find displacement. If you're finding displacement like through the actual position and like how you find displacement, are they two different numbers?
so if you're finding displacement through the actual position function, you have a function that tells you where they are. So you don't have to do integrals or derivatives.
Oh, but sometimes
Because that position function will just tell you where they are at particular times. But if they give you velocity, you can find how much they travel between a certain time. Like if you know someone's going 60 miles per hour, if you know how long they've been traveling for, you can figure out how far they travel. Does that make sense?
yeah.
If you know that they've traveled 60 miles over certain times, you don't need to do a derivative. You just say the displacement is 60 miles because that's how far they traveled. So that's the thing you have to draw the connection here is, are they telling you position? Are they telling you velocity? Or are they telling you acceleration? And now we got to figure out what we can find from that, okay? I know this sounds weird, and it is weird, but let me show you a problem, and then hopefully it makes a little bit more sense. The problem with these types of problems, though, is that they look complicated, and I need you to not freak out at how complicated they look. They're just complicated just because most people who travel don't travel in a steady line. They sometimes go forward, and sometimes they go backwards, sometimes they go forward again, right? So these functions are going to be a little bit more complicated because it goes back and forth. So let me show you this problem before we end for today.
Show us?
Yeah, I'm going to copy this and then put it on the screen. So let's do this one right here.
What?
Okay. So don't write this down. Just give me your attention for this one, because it's a lot. And then you can copy the notes down later if you want, or take a picture of it. All right? So let's say here a particle moves along a horizontal line. So pretend that I'm a particle, and here's my horizontal line, right? And it follows this equation for the velocity of it. So if t was equal to 0, I plug in 0 and then see what I get. I believe that would be 0. So I can see that at t equals 0, it's going to be either a positive or a negative number or 0. It's either going to be going forward, it's either going to be going backwards, or it's going to be staying still at t equals 0. This function represents the speed. So if t was equal to 1, after 1 second, I can figure out how fast this thing is going after 1 second. If t is equal to 2, I can figure out how fast it's going at 2 seconds, right? The position is given by s of t, and they don't tell us anything else other than s of t is the position function, and at the start, its starting location is where? So if the position here is 0, negative 3 would be 1, 2, 3. So it's starting here is what they're telling us. It's starting at negative 3, and it's going to be traveling some velocity. So it's either going to be going forward or backwards, okay? Find all values of t on the interval from negative 4 to 7 for which the speed of the particle is what? 5. So using a calculator, I'm supposed to figure out when does the velocity equal to 5. I don't need to do any calculus. I don't need to do the derivative because it's already the velocity, right? And all I would have to do is graph this and see when does it equal to what?
5.
So I'm not solving this algebraically, by the way. I don't know how to solve this algebraically. But part A, we're going to skip that. That's a very simple, like, when does this thing equal to a speed of 5? You just graph it and see when does it equal to 5. Okay? I'll show you that next time. But this is the bigger one right here. Write an expression involving an integral that gives the position s. Use this expression to find the position of the particle at t equals 3. So, you ready?
Yeah.
If I was looking for the position function, position is going to equal to this. The position of s of t is going to equal to the integral, right, from, where are we going to go here? Knock me. Give me a second here. I think, yeah, we could go to 3, but I think it would be easier if we just go to, I think you were right, 0 to 3, right? We're starting at 0, yes? So I'm going to go from 0 to 3 of what function?
T minus 3.
Yeah, that entire thing, right? I'm just going to write it as v of t, dt, yes? So this will tell me the position, right, from 0 to 3, or I'm sorry, the displacement from 0 to 3, plus, where does it start? It starts at negative 3. So you take that into account. That negative 3 is going to tell you where to start. This right here will tell you the total displacement from 0 to 3, and that will tell you the position. Does that make sense?
Yeah.
So it's a little bit trickier. Like, when you do derivatives, that just gives you the function, right? When you do the integrals, you have to know where it starts, is what I'm trying to say. You can figure out the total displacement, but if you don't know where it starts, you don't know if like you know what I'm trying to say here? If you ask somebody, hey, you're going 60 miles per hour, which is the velocity, and they traveled for an hour, how far did they travel? They traveled 60 miles, right? But here's the thing. Did they travel 60 miles from Lawndale, or did they travel 60 miles from San Diego? You know what I mean? So their position will be different based on where they start. When you do the integral of these types of functions, you have to take that into account now, is where do they start? You notice that when we did all those integrals before, I kept having you write down plus c?
Yeah.
That plus c is your initial value.
Oh.
That plus c was always there to say, like, this is a counter of where you're supposed to start. What we're going to start doing now is start solving for that c, okay, to figure out where they start. In this case, though, they just kind of give it to us, which is nice. But that's the connection that I want to make to start us off on this chapter, is that position, velocity, and acceleration sound weird, but it's the biggest part of this calculus stuff. It's the biggest connection you can make. Derivative of position is velocity, derivative of velocity is acceleration. The antiderivative of acceleration will get you the velocity function, but you need to know what the start velocity was. You do the integral of velocity, that will give you the position function, but you need to know where the position starts at the beginning as well, okay? All right, anyways, I'm gonna pause here and we'll continue this next time. I need to pass out your tests.